Here the derivative rules. We have the two derivative rules we are going to check about it now. First, derivatives of exponential functions, and the second, derivatives of logarithmic functions. Let's start from derivatives of exponential functions. Have you tried to determine how can we use by the proof up here? If f of x equals to a to the power of x, a greater than 0, then f derivative at x must be a to the power of x ln a. If f of x must be e to the power of x, then f derivative at x must be limit x t approaches to x, e to the power of t minus e to the power of x minus over t minus x. We can go to the proof of derivatives of exponential functions. We have a proof determinations. Here. Thus, f derivative at x limit h approaches to 0, f times x plus h minus f of x over h must be limit h approaches to 0, a to the power of x must be a to the power of h minus 1 over h, a to the power of x, limit h approaches to 0, a to the power of h minus 1 over h, which is equal to a to the power of x ln a. Practical examples on derivatives of exponential functions. Here, f of x equals to 4 to the power of x, and here we can check. F of x equals to 4 to the power of x. When we derivate it, it's become f prime x must be 4 to the power of x ln 4. Then f the power of x, f of x must be root of 5 to the power of x. F prime x must be root of 5 to the power of x ln root of 5. Then f of x must be pi to the power of x. F derivative at x must be pi to the power of x ln x. So this is what here. Derivatives of logarithmic functions. If f of x equals to ln x must be x greater than 0, then f derivative at x must be 1 over x. Let's prove over here. Let f of x must be ln x. F derivative at x must be limit x h approaches to 0, f times x plus h minus f of x over h, limit h approaches to 0, ln times x plus h minus ln x over h, limit h approaches to 0, ln x plus h over x over h. Then limit h approaches to 0, ln 1 plus h over x, half of the whole 1 over h, which ln of the whole limit h approaches to 0 times 1 plus h over x the whole of square 1 over h. Ln times e 1 over x must be 1 over x. So the f of x equal to log base a x must be ln x over ln a. F derivative at x 1 over ln a. Ln x derivative 1 over ln a x times 1 over x must be 1 over x ln a. Practical examples on derivatives of logarithmic functions. Here, f of x must be log base 2x, f of x log x, f of x log x cubed. We got the answer here the correct way. The f of x log base 2x must be f derivative at x must be 1 over x ln 2. F of x must be log x must be f derivative at x 1 over x ln 10. F of x must be log x cubed. F of x must be 3 log x. F derivative at x must be 3 over x ln 10. So this is all about for the learning, and next week we're gonna learn about applied mathematics, derivatives of trigonometric functions, and the operation of differentiations and their derivatives and their rules.